Hello there. Today we're going to talk about simplifying radicals. A square root is simplified when the radicand contains no perfect square factors. So what does that mean? Well, let's take an example. Here we have a square root, the square root of 20. And that's not simplified. We can actually simplify that square root because 20 is not a perfect square, but it can be factored into 4 times 5. And we see 4 as a perfect square. So what we're going to learn in this section is how to simplify these square roots. In fact, if we look at this more closely, we can take the square root out, the square root of 4 out, and write it as the square root of 4 times the square root of 5. And we know how to square root 4 because 4 is a perfect square, the square root of 4 is 2, and so we'll have 2 times the square root of 5. So the reason we can do this is based on the property of square roots, which we'll talk about now. What this property says for square roots is if square root of a and the square root of b are real numbers, then, so they exist, we can actually have square roots of a and b, then the square root of the product of a times b is equal to the square root of a times the square root of b. We can separate out those numbers on the individual root signs. Similarly, the square root of a divided by b can be separated out as the square root of a divided by the square root of b, as long as b is not 0, because you can't divide by 0. So these two properties allow us to simplify radicals. We're going to take a few examples to illustrate this point. Supposing I'm asked to simplify the square root of 45. Now it's not simplified because 45 is not a perfect square, and there are numbers that can go into 45 that are perfect squares. 45 is 5 times 9. So I can rewrite the root of 45, the square root of 45, as the square root of 9 times 5. And we can now separate out these square roots. This is the square root of 9 times the square root of 5. And the square root of 9 is 3. The square root of 5 we cannot square root any further, and so we leave it as square root of 5. And so the square root of 45 is also 3 root 5. Simplified version is 3 root 5. Let's take another example. Suppose we want to simplify 3 times the square root of 8. Now you might be thinking this is simplified already, but 8 actually can be broken down into two numbers, one of which is a perfect square. 8 is 4 times 2. So we can rewrite this as 3 times the square root of 4 times 2, and the square root of 4 is 2. So we can actually pull out the root. I'm not going to go through that intermediate step. We can see the square root of 4 is 2. So we go 3 times 2, where that 2 is coming from the root of 4, times the root of 2, because that 2 is what's left underneath the root, the radicand. And 3 times 2 is 6, so that's 6 times the square root of 2. Now you can check on the calculator that actually these two numbers are the same. So 3 times the square root of 8, or 3 root 8, is the same as 6 root 2. Let's take some more examples. So here we're asked to simplify the square root, and this is a quotient, the square root of 25 over 36. So this can be separated out according to our rule as the square root of 25 over the square root of 36. And these can be square rooted. These are perfect squared. Square root of 25 is 5, and the square root of 36 is 6. Let's take another example. Suppose we want to simplify the square root of 40 divided by 81. So again, we separate them out. So we'll have the square root of 40 and the square root of 81. Now, the square root of 81 we know is 9. So this is the square root of 40 over 9. However, the square root of 40 is not simplified. We can simplify that. We're thinking of two numbers. When I multiply them, they're going to give me 40, and one is a perfect square. So we can think of 8 times 5, but that's not going to work. And maybe 4 times 10. So 4 times 10, 4 is a perfect square, so we could try that. So this can be rewritten as square root of 40 is the square root of 4 times 10. And that's all over 9. And then the square root of 4 can be taken out as 2, because 2 is the square root of 4. So this is 2 times the square root of 10 all over 9. And there's your simplified version. So the square root of 40 over 81 is the same as 2 root 10 over 9. Now what happens when we throw some variables in here? Well, let's take a look.